How's it going, folks? Rosendo from MLH here. Coming back live. It's day 3 of Global Hack Week. Really excited to have y'all here. Honestly, it's going to be a great workshop. I know that you may have just wrapped up in session with Kari, who was teaching y'all how to do your resumes. Now we have another opportunity for you to learn a little bit about other ways to basically get into green software, sustainable software, and basically support those initiatives as professional programmers of the future. It's going to be great. We're being joined today by someone who is actually quite influential in the space. If you're into, I don't know, aerospace engineering, I think Tobias might have something in store for you in terms of, being able to sort of glean things from his existing wisdom in the field. If you want to check in, if you want to register and get checked in, the workshop link is right there at the bottom of the screen. You can also ask any questions in chat. We'll make sure that we are collecting them for you throughout the workshop so that you can stay like basically informed about like the things that are interesting to you in the workshop itself. Yeah, so that's it. I mean, without any further ado, I'm going to go ahead and get Tobias up here. Everyone, please give him a warm welcome. How's it going, Tobias?
Oh, I'm fine. Thank you so much to be
All right.
here.
Yeah, no worries. We'll see you later.
So, yeah, welcome to Hacking Earth from Space with Open Source. My name is Tobias Augsburger. I hope you can see my screen. I'm actually the founder of OpenSustain.tech. That's an open source directory of all the great open source projects you can find in environment sustainability and climate tech. So let's get started. So what is Open Sustain Tech actually? So we are a free and open community with a common mission, and that's preserving and strengthening of the environmental open source ecosystem. So we are really just a bunch of people that come together and do this. We have no company behind us or any larger organization that is helping us, but we are just really a group of, at the moment, 7 people that come together every week, and we decide, okay, what kind of project, what kind of presentation, what kind of things we can actually do to support this open source ecosystem as a whole. So the first thing we actually did 4 years ago was to really create a directory of open source projects in this field, because we realized nobody had really a clue what's relevant, what's really active, what are the good projects that are documented, that are really open source. That means that it really has an open source license. So, and after that, 2 years later, we actually started together with the Linux Foundation to analyze all those projects, because the good thing about open source is they're normally stored in Git repositories. And if you have a Git repository, you can automatically gain a lot of data from all those projects and the organization behind it. So we could create a whole report from that that's called the Open Source Sustainability Ecosystem report, together with the Linux Foundation and Subak and another company called Open Corridor. And we found actually a lot of very interesting stuff about what's the organization behind all those projects, where they're coming from, what's the trends at the moment. And another thing we started like last winter actually is to create platforms and ecosystem support to empower those whole ecosystem. The first thing we did is called climate triage. I will come to this later on. But we are also working now on another project called Open Climate Fund to actually find and to provide more funding for those open source projects. So let's start with environmental sustainability. What's that and why do we doing this? So environmental sustainability is really about preserving the natural resources of our planet for future generations. So, and to do this, you actually have to manage, because humans are so strong and so powerful on this planet. We need to think about, okay, how do we manage actually those resources? How do we manage nature? It sounds crazy, but we really have to think about this. How do we manage it? And to do this, we have to simulate it and to understand it, how it actually works. And that's, let's say, the first step. You see on the right-hand side is really a simulation of the whole Earth, and how water vapor actually changes our Earth and the atmosphere. Because when the Earth is heating up, there will be much more water vapor in the atmosphere, and this will change everything on our planet. And we have to understand how does it change our planet so that we can actually manage that. So the basic idea about and why we do this is really that we need to quantify sustainability so that we can make it as part of our taxes, of our sustainable investment, of our planning, in part as part of our governments, and as part of our justice and policies, labels, and insurances. It's really about making those numbers relevant inside of our systems that we build, political system, economic system, and financial system. If we don't do this, if we don't make those numbers count as physical numbers, then they're actually worthless and we can actually not reach sustainability. And numbers are today created with software. And the best numbers you get with open source software, because in this way they're traceable. You can work together with on that, and you can actually understand how numbers are created. So one very important aspect of environmental sustainability is really the intelligence to understand the Earth with sensoric, from in situ sensoric, that means placed on ground, but also with satellites or from an airplane. And in this, we can really quantify air quality, forest change, the noise, emissions, biodiversity, urban vegetation, or heat islands, and much, much more. And this is actually what I want to show you as part of this presentation. What is really the insights that we can create from space about how we can actually preserve Earth. So with those insights, we can then create technology that's, for example, on the left-hand side, you see actually a whole wind turbine that has been developed open source with 50 megawatt, with all the simulations, all the CAD files, all the software is actually running inside the wind turbine itself. But you also find a lot of software that's really about simulating a photovoltaic device, how to orientate it, where to put it, what's the best numbers of photovoltaic cells to combine. So there's so many things about photovoltaic systems that you can simulate to really get the most out of it, that I'm still impressed what's going on there. And there's also like open source projects like Pipesar that really simulate the whole energy grids worldwide. You see it here. See on the right hand side the energy grid of India, and how it really is, how the network between the different power plants look like, the different photovoltaic or wind turbines. And you can also use such tools to really plan for the future. So how does the electric grid needs to change so that we have maybe a more environmentally sustainable energy supply. So let's start a little bit with open source projects that over the last 4 years I really appreciated, and I think that gives you a good impression what are the different topics you can get involved, and how do they really have impact and why do they matter. So one of the most impactful projects I know is the Global Forest Watch. It's really measuring with satellite data and other Earth observation techniques. How does the forest change? Where do we lose forest? Where is the forest coming back? And so in this way, we have really a traceable platform that scientists, but also a lot of companies and governments worldwide can use to have an understanding about how does the forest actually change. And the good thing about this idea to have it open source and in an open science way, you sometimes say, is if people don't trust this or don't think it's the right thing that you see or the numbers are not correct, they can just look into the code. They can look into the numbers really involved into this platform. Another project I like very much is machine learning for floods. It's it's about floods and to use Earth observation data, not just normal RGB data you see here on the left-hand side, you see with your eyes, but also like radar data. They've used a lot of different spectra with each other so that they really can map what's actually the extent of the flood, where's help needed at the moment. But they can also use such method to actually predict in the future where might be a flood in the future, where's maybe a bad idea to build your house or your industrial site or whatever you want to build there. So this kind of software really matters because they help you and insurances especially to give you the good numbers about where actually floods are coming and what's the extent of floods. So one open source project that I also liked a lot is called MITRE Fireline. It's actually using a game engine to really simulate how does fire actually spread. And I think they can at the moment do it for the whole United States and try to extend it actually to the whole world so that you have an idea about how fast you should get away, or maybe what are actually the streets that you can escape. And you will find a lot of similar open source projects that are really trying to simulate and also to predict where does actually wildfire threaten our life and the life of our of nature itself at the end. One project, a project I really loved also is CoastSat. It gives you the shoreline, you call it, about where actually does the ocean end. So, but for the whole world, that's the thing. And this really matters also, again, for example, for insurances. If you want to know how does the coastline changed over the last 10 years, you can use such an open source project to give an impression about, okay, maybe here's really something where we have to build something to protect those cities. Then there is much more, and this is really something that is coming now. This trend that is coming more and more is to use satellite data and a lot of other different data that is merged with each other to understand what's actually the nature that is really worth protecting. Where's a lot of biodiversity and how do we protect it? And for this planning about what's actually what's nature, what's really nature that is really strong and that we needs to protect it, but also maybe where areas where are a lot of animals living where that are maybe on some red list that need to be protected. You can find this out with open source software, and this is very important to do it in open source software so that you can scale such a project worldwide, and that you have, again, like with Forest Watch or all kinds of this project, that you have to trust that somebody can look into your numbers. And maybe they are not right. Okay, maybe they are wrong. But at least somebody can improve your calculations, and that's the core idea. So one project from Belgium, actually, that I love a lot is called soil erosion, because within heating world, we will lose a lot of soil, and if you have no soil anymore, you cannot grow anything anymore. And that's why they try to really classify, that's mostly done actually with AI, what's the kind of soil, what's the kind of vegetation, to actually, again, do also conservation of nature, and also to understand, okay, here the soil is really in a bad shape, we have to change there something, maybe in agriculture. So one project actually from Australia, but I hope they will also scale it worldwide, is called Open Methane. So maybe you heard, besides carbon dioxide, actually methane is a very strong greenhouse gas. So, but it's the problem with methane, it's over a short time scale, it's much stronger than actually carbon dioxide. So people try to avoid methane worldwide, and there's a huge benefit from avoiding it. So what does Open Methane do is really to use a combination of satellite data and, again, atmospheric modeling to find out what and where are actually methane point sources. So you can really say, hey, this company here or this this mine here or whatever is actually releasing this amount of methane. And you can have a look actually in their reports and look into it and say, is this actually the methane that they reported that they emitted? And this is getting very interesting because sooner or later we will have a carbon or methane at the end. It's actually the same, and somehow a tax about such emissions. So somebody needs to measure actually and validate if this is true or not, what those companies are reporting. Okay, let's have a look. Next slide. Yeah, one company I also like a lot from actually Great Britain, but I also think they want to scale their product worldwide, and this is actually possible because they use an approach that is scalable worldwide as long as you have a geofixed satellite, is to measure the amount of photovoltaic power that you can get for the whole United Kingdom. In this case, they know the position of the larger photovoltaic power plants. They exactly predict and also where actually are clouds being created. And in this way, they can very precisely, you call this technology nowcasting, what's the photovoltaic output in maybe 1, 2, or 3 hours. So this will help you to actually scale your coal power plants. You can say, oh, we don't need this gas power plant, for example. We don't need more coal now in the grid. We will have enough photovoltaic for the next hours. And in this way, they actually save a lot of carbon by doing this. All those predictions are, especially from Open Climate Fix, very machine learning driven. So yeah, another project called actually Skyrim is using they're using actually all those satellite data, all those data from our atmosphere is being fed into a really big, large, into an AI, into a neural network. And in this way, they can actually do forecasting with a precision, with a quality that was never possible on consumer grade GPUs. But nowadays, you can actually simulate with the same quality the whole world and the atmosphere, like people did 10 years ago with a complete high performance computer with, I don't know, hundreds of CPUs. So with AI, suddenly you can simulate and predict also the atmosphere of the whole planet. One project I also liked a lot is actually coming from NASA, and maybe just as an idea, if you are, or if you want to join NASA, actually going through such environmental project is maybe the best idea, because here, this is where a lot of NASA technology is really relevant for us on the ground, for us, for our daily life, because they really provide a lot of really great data from the whole world, and a lot of scientists are using it. And it's all open source, all technology and all the sort of tools they are using, they're also open source. So you can just go there, use their tools, use their data, and just try to, for example, like in this case, measure the extent of a glacier and see how Greenland, actually, let's say the biggest glacier in the world, how it's shrinking. And actually, that's the idea of It's Life. That's the website. They are measuring, and that's again possible with satellites because they rotate all around the world. They are measuring the glaciers from all around the world and give a good impression about what's actually happening there. Are we losing ice or not? Are actually the glaciers and the poles, are they melting or not? You can be part of this actually. They actually, and you can, with a GitHub account, just contribute to such a project. You don't need to be part of NASA, but maybe this is a way for you to actually get into NASA. So maybe one of the most impactful open source projects from NASA that I could found is called NASA Harvest. What they do is really, again, using satellite data to map the extent of different crops worldwide, and also the extent of those fields. And they can actually also measure the health of those crops. And in this way, they can predict hunger in the world. Not from all you see here, the countries they are doing it for at the moment, but theoretically they can do it for the whole world. And it's really fascinating. And you can join such a project, not as an official member, but as an open source contributor. And you can also use it maybe for your country. You can get this whole data set they created actually, and use it for your own purpose. I actually expect that you are not, let's say, super familiar with geoscience or with climate science or with actually earth science, it's also sometimes called. And if you want to get into that, I can really recommend you two books. And you say, okay, and it's again a book, but it's not actually open source books. That's the point. You can actually contribute to the book itself again. And there are actually two, let's say, programming languages that are used the most at the moment in this area. There's Python and R. There's also now Julia coming. And if you want to develop an app, then you have different frameworks and programming language. But if you're in the science part and you want to create data and want to, let's say, create insights, then this is the programming languages and the books I can recommend you to get started. There's also, if you really want to get into it, there's a book called The Climate Laboratory. Again, completely open source. You can contribute. You can also just read it. It's free. But from a very famous climate scientist, Brian Rose. And this actually I find it fascinating because it helps you. You can learn Python and the basics of climate physics at the same time. And you actually can really simulate yourself climate change and understand how climate change works in a Python workshop. Very cool thing. Not that easy, but I still think it's a very good way to get started if you are interested in these topics. So, but you will also if you're more into, for example, air quality or in ozone, you will get all those data. And sometimes I cannot believe how much open source software and open data is actually out there that you can use for actually also a lot of those data for commercial use. On the left-hand side, you see actually the ozone layer, the total ozone column. And this is the Antarctica. And you see, people say, okay, the ozone hole is not a problem anymore. It is actually still a problem, but you see it's here on Antarctica. And you can create those plots by yourself, and you can try to understand where is the data coming from. It's not that hard as you might think, because everything to do it is really set in place for you in a Jupyter notebook very easily. You can run it in, for example, Google Colab without installing Python on your computer. On the right-hand side, you see actually aerosols that are created from, for example, wildfires. Aerosol really change our weather. They can have a huge impact on your health, on very different kinds of atmospheric quantities, also on atmospheric chemistry. You can get all those data. You can you can get much more data actually about air quality from the Copernicus platform. So if you really want to get into it, then the Environmental Data Science book by the Alan Turing Institute is maybe also great where to start. You have small tutorials about how to understand the ocean temperature. The coral reefs are dying because the ocean temperature is is increasing so much. Or you can understand land cover. So land cover is really, or land use, really important aspect of sustainability. Because if there is no, if all the land is used by agriculture, then there's no place for nature anymore. You need to understand, okay, how does this change? How does actually land use change? And soil moisture, soil moisture, you can imagine if there's no soil moisture anymore, the plants will die. Yeah. So it's really about, and rainfall, monthly sea ice forecasting, tree crown, whatever. There's so much things you can get from the environmental data science book. It's really impressive. Also all open source, you can imagine. I only present open source project. Would never advertise anything else. If you want to know more or really want to get into this topic, there are actually two ways to do it. One thing is you take one of the educational resources in open sustain tech. We over the last 4 years have tried really to map those educational resources that are beginner friendly on the website on a different section. Educational we call it, or educational resources. You find really great resources from NASA there. Also about the Earth data. That's actually really a platform, but you can imagine what you get there from the as data. There's also now the TOPS. It's really about NASA. What was TOPS? NASA's really going open science now, and there's a lot of initiatives inside of NASA to get more open science involved as part of NASA. And in this way, you find a lot of cool stuff, actually, how to participate in those things. Yes, and the same thing goes also if you are, let's say, a little bit more experienced, you can look into the project PyFear, it's called. That's actually, let's say, resources that are more for the advanced scientists that have, let's say, if you have a master done or are in the middle of the master, you could have a look here into that. Okay, and as I said, we also are building our platforms on all those open source projects. At the moment, we have, I think, about 2,100 projects mapped in all those different areas. You can just really click. You can say, okay, I'm a Python developer, and you get all those open source projects that are in Python. You can say, hey, I'm really interested in the atmosphere. You get a lot of those projects. I must say, this is a hard way to get into it if you are not experienced with programming or environmental sustainability. Because here you really get the hard issues that I have in the project. Let's say not the hardest issues, but this is really being part of those projects. But those projects, and that's the way actually we map them. On GitHub, you have so-called good first issues. And they actually, so the projects put those labels on the issues that are beginner friendly and to get more people in the boat. And we actually automatically get those issues from GitHub with the help of a platform called actually Ecosystems. It's a partner we are working with. And in this way, we map all those projects. You can actually also sort them, but what's the recent issue? What's the age of the project, download numbers, stars, whatever. So you really can use that if you have a certain amount of experience and you just want to see, okay, I want to use my time. I'm a programmer. I want to use my time, my free time for maybe something that is sustainable. You can find here the projects you're looking for. So that's actually it. We are Open Sustain Tech. You can contact me on Tobias Augsburger at prototypes.eu. Actually, Prototypes was the organization that we actually started with. At the end, it's all got Open Sustain Tech. And we're doing public workshops. You find them actually if you go on Open Sustain Tech and you click contributing. Then you get to our calendar and then you find our public workshops, but you can just also write me an email. We're looking for sponsors and people to collaborate with and organizations. I also want to show you one thing. I just realized that I should show you. We just, okay, show you here the website again. You should see it. We have here actually the spreadsheets. You could just, that's actually our report that we did. Okay. You see here, that's actually the spreadsheet. We have much more metadata actually as in the list. You can sort it by different aspects, if it's active or not. You can, what's the platform, what's the programming language used, the license, what's the category, whatever. But you can also, and that's very interesting, maybe for you, if you want to join such a project or actually want to work in the space, here are the organizations behind the projects. That's about more than 1,000, and you can also sort them by the country. And you can just have a look, just go through them. Maybe there's something next to you where you can participate. And if you want to read our report, just click here. If you want to have a look at our educational section, it's all here. I must say, okay, our front end is not the best. It's not the best user experience so far, but we are working on getting this better. We also have a podcast actually now. It's together with Richard Littauer. If you want to just listen into it and have just an impression, we just try to interview really some really impactful people in the space. And if you just want to follow what are the new projects that we have found, then you just check our Mastodon account. You'll find all this here. So, and just let me just go back here. For any questions that you don't want to ask in the chat, please go here. Okay, just write me an email. And I'm very much looking into your questions. So,
Hi, Tobias. It looks like folks are still getting their questions ready for you. I did have a couple of things, I maybe wanted to pick your brain on behalf of some of the folks that could be joining here. I know that you're currently working on a PhD. You're obviously very skilled within the field of climate sustainability and just all of these open source projects that you told us about. How did you first start getting into climate action and climate sustainability tech in open source software? And where would you suggest someone that is maybe a very beginner level person that is interested in green software, where would you suggest for them to begin?
Okay, so I got into the space. Actually, I worked for DHL, and we built actually autonomous vehicles for logistic tasks. And I got there, and then we had to build a group of people or the whole team of people that actually were able to develop in robotics, but we had no clue about robotics in general. So actually they were all youngsters, nobody had any clue. And then what we did actually, we used the robot operating system. That's another framework, an open source framework.
Mm-hmm.
And this really helped us and helped me to understand open source, because suddenly I understand, hey, open source really is super powerful. There's so much things going on there. Most of the website, most of the AI tooling, everything is today open source. That's when I started realizing this. And I learned this really the hard way by, actually our CTO said, you have to do it on your own. I want the algorithms and the software. I want to have this inside of my company. I don't want to buy the software. Find a way to get this in-house and to develop this with a group of youngsters that have no clue. And this is, an open source made this possible. And Um, After, let's say, 5 years, I I realized, okay, I want to use those skill set for something, let's say, this has more impact. This has something more domain sustainability, and that's how Open Sustain Tech actually started. And then I realized, okay, this makes me fun working with Open Sustain Tech, mapping those projects, really looking into it. And then I started actually a PhD with this project. If you want to get started with um, open source in general, I think it's good to be a user. So maybe start with Linux. Maybe maybe if you're a gamer, you're aware there's also now a console that have a Linux installed on it, like the Steam Deck, for example. I don't want to be advertising here at the moment, but you get involved into maybe as a user. I also started as a user, and maybe install Linux on one computer, and then try to get into it. And I also would try to find something to do it with. Maybe it's one or two persons that are interested in, because starting it on your own can be hard. But if you have somebody to get in, to exchange ideas, experiences, that's the most easiest way. Actually, my neighbor showed me how open source worked 10 years ago, and really fascinated me. And then this happened at the same time when I was working at DHL.
That's pretty fortuitous of you to have a neighbor that knew about open source and was able to actually tell you about robotics open source at the time that you were at DHL. So I think just to kind of synthesize all that, like, be hands-on, be curious, use open source technology to sort of expand your experience within that field, within that segment of software development, and eventually find something that sort of like fits in with your personal interests.
Yeah, sometimes people call it a pet project. It's actually not a bad idea to have it, not to have a real pad at home. Maybe you have to maybe think of an open source project you're actually using and you can really learn from. There's a lot of cool stuff now going on in home automatization, for example. Like how's it called? The big one. It's the there's the home. No, how's it called? There's a lot of home assistant things going on open source. Home assistant. It's just called home assistant. Yeah. This is actually also a great way so that you really, let's say, have a benefit yourself from it. That you can try, experiment. That's a good thing. Yeah, Raspberry Pi is also something I start learning with. Yeah.
That sounds great. Quick question from my side, just with regards to, I know we shared a lot of different projects today, and you kind of gave a very high level overview of several of those projects. In your work, like, which projects, like, where do you think people should focus if they wanted to, like I said, start to get into green software, but at the same time, like, like, make the most impact? Like, what in your opinion would be like the best starting point for them, in terms of the projects that you shared?
The best starting point to get started, that really depends on your skill set. It's if you have really, I think there are organizations in green software. So let's say it in this way: green software is really just reducing the energy consumption of software. That's part of what we also are looking at. But what we are looking at, actually, how can actually open source benefit for sustainability in general? So there's this both sides. If you're in green software, then there are really great organizations out there that the Green Software Foundation, the Green Web Foundation, there's Climate Action Tech is really great community. These are green software communities that actually are very strong, and to to get into such an organization is, I think, a good way to get started. They also have very beginner-friendly tasks. Yes, so that's, I think, is the easiest way to get started. Because, yeah, green software is actually a little bit easier. It's about, okay, I want to reduce the amount of energy or resources that actually software needs.
Hmm.
Earth science is really harder, I must say. Okay, you
Yeah.
have certain understanding about physics, but it's getting more and more relevant. Also, a lot of projects I showed you are, let's say, from an academia, nonprofit side, but it's getting really into for-profits now. You can make money with that. Yes.
That's awesome. I mean, what you're saying right now makes total sense. I think it kind of ties into the next question here. Steeloy Bits asks, well, first mentions, great talk, lots of amazing stuff you've shared. I recently learned about sustainability in tech, and I quickly embraced the concept of trying to protect our planet. So currently, I'm preparing a talk on this talk. As an expert, can you suggest an overview of how to progress the talk to a larger audience of core developers?
Yeah, it's so first thing, it's if you talk about sustainability, it's really, if you Google it, for example, it's very confusing. There's
Mm.
open source sustainability. That's something totally different, actually. So you have to be clear with your wordings. That's really you get started, because at the end, when people are searching for it, they cannot find what you mean. So there is actually open source sustainability. That is how to make your open source projects sustain on the long term, to make it actually run for years. Okay. Then there's green software. Sometimes people call it green IT, or that's really about reducing the amount of resources. Then what we call is actually open sustainability sometimes, or open source and sustainability. That's really about how to apply open source principles in sustainability. I think this is a good way to get started. What I learned, I showed you this at the beginning of the slides. When I started this project, a lot of people told me software is not so relevant for sustainability. It's not so relevant for climate. We need hardware. We need better hardware. Yes, but today every hardware is created with software. And if you don't put into your decision making, if you don't put sustainability as part of your design process, and that's actually software, how you build things, your hardware will not get sustainable at all. So we this thinking about we need good numbers, we need traceable numbers. That's really relevant, because in the past there was a lot of manipulation just with numbers. Like if you have on your products carbon neutral, something standing on your products.
Hmm.
This was problematic, let's say it in this way, and this will change in the future, because yeah, a lot of people said you cannot trace this statement to numbers. You cannot prove it, and with numbers, we can prove sustainability, and that's something we have to do in the future.
Absolutely. Yeah, getting the data out there will definitely progress it to a larger audience of developers. I think folks are really wanting to know what the actual impact is in some of this work. So if that's something you're looking to do, definitely try to dig into the data and show us what's happening in the space. I think great way to frame your message. Um, Moving on to the next question, we've got Dev SG13 asking, what would be some beginner open source green software projects we can get into, or is there a specific tech stack which is popular in this field? I know you've already, I know Tobias, you've already mentioned like a good
Um,
amount of open source projects, but I
yeah,
guess if you could just
I
review
can
once again.
I can show you just something if you're
Mhm.
interested. And sometimes I find it very interesting on this question. Let me just have a look if I can actually reproduce this very quickly. Um, I hope there is. Um, let's say it in this way. Um, don't think in stars. Okay, if a project has a lot of stars, it might be not the most impactful project. It only means that this project actually did the best marketing for itself. Well, maybe it's the same thing, but I found out actually in green software, interesting thing is that there is some projects that are downloaded a lot, that are used a lot, but they don't have so much stars. So maybe have a look into the download numbers if you are able to do this. Sometimes it's not that easy, but um, you have to make it really beginner friendly. Is yes, so green software really is about understanding how software is being used. So you have to understand a little bit about the deployment and workflow of software. For example, a lot of people say Python is not very sustainable green software because it uses a lot of resources, etc. But actually it is, because the software is implementing a lot of other programming languages. And when you have something that is, for example, NumPy, if you want to do a matrix manipulation, you don't do it in native Python. That's not something you should do. Use NumPy, and in NumPy, this is implemented in C. So this is actually fast. So I must say, green software is just really not that easy. You have to get a certain sense about it, about actually how often is this algorithm actually being used. If I just want to plot a map of the world and it's been plotted one time, then it's Python is maybe the best way to go because it's fast, it works. You don't have to spend days with that. So really try to understand the usage is, I think, relevant to get something that's impactful. Yeah, and Climate Action Tag, the Green Web Foundation, that's a way to get started.
Awesome. Yeah, I'm just grabbing the websites for Climate Action Tech and the Green Web Foundation here. Yeah, if Dev SG, if you want to kind of like take a look at the comment section here, you'll be able to click into some of those primary websites for those foundations and organizations that Tobias had mentioned. On top of that, like I'm sure once you get into that website, you'll be led to the GitHub repositories and the open source projects that you'll need to implement yourself if you want to get started. So, yeah, great stuff. I'm looking in the chat here. Doesn't look like we have many other questions. I do want to just say this to be really, really thankful for the time that you took here and very informative session. There were a lot of projects that were shared. What I'll do is I will synthesize that list and get it out to the community in Discord so that they can have
Cool.
evergreen access to it along with the recording to the session. And yeah, really, really, I hope to see more work in this space. I think, it's very interesting to me when I think of aerospace engineering. I think of people going out into space and maybe going, like putting on an astronaut outfit. I must admit, you've opened my eyes to the fact, like, yeah, you can send up satellites, take a look at the Earth from space, and that does require a certain amount of aerospace engineering as well. So obviously, something that was probably a little bit more obvious to others, but to me, still an eye-opening experience. So I appreciate that. And yeah, I mean, if you have any other closing words that you'd like to say, happy to take a couple of minutes here to give time for that.
No, it's just, yeah, if you have any questions, just write me an email, or you can also find me on LinkedIn or Mastodon. Just, yeah, write me a message there. I can always help you to find something that fits your skill set. There are a lot of projects out there. That's actually my job, or I see this actually as my job. And I can also tell you, it's when I started this, a lot of people always say to me, this is very idealistic, you don't get a lot of money out of this, etc., etc. Actually, I found now a very good paid job with those lists, actually working in the space, because this remote sensing stuff I showed you, this is used in a lot of things, not just about sustainability, to be honest, but working with satellite data or simulating satellites. This is really something powerful. And it's not that hard. I'm not the super smartest guy in the world. I just was dealing a long time with that, and after a certain amount of time, you get a feeling about stuff. One thing might be a lot of people, when you do open source stuff, always have a look if there is actually another community or another project already doing this. Don't, and there's a lot of beginners start from the green field. It's um, it's a not if you do it for educational purposes, if you want to learn it from the hard way how the wheel works, then you have to reinvent the wheel. But if you want to participate and to have impact, use existing open source tools and try to combine them. Because I learned actually in robotic, they were starting and to create whole frameworks by just putting a lot of open source projects together, and suddenly the robot was running, you know. And in this space, I must say, I'm a little bit missing that. This idea of, and that's why we are also in the background working on an environmental operating system, we call it. What I personally think is, how can we combine those tools the best way to build something that people just can get started, don't have to hustle with installing things. It just works. Here, this plugs together. This API works with this project. Okay, let's get started. That's something that is really important to think in this way, because open source is really like Lego. Actually, I forgot to integrate this slide into the presentation. Yeah, that's maybe good closing words.
Wonderful. Yeah, Tobias Oxberger at protontypes.edu, opensustain.tech. If you are curious, please send out an email. I will have the links for you in Discord as well. Sounds like, hard work, curiosity, and experience over time is what sort of led you here to this point in your career. So that's awesome. Really looking forward to seeing what y'all do next. And also, yeah, I'm Rosendo from MLH. It's been great having you here. Thank you so much, Tobias, for lending us your time and your wisdom. Really looking forward to what Open Sustain Tech does. OpenSustain.tech does next, obviously. And yeah, if you have any other questions, feel free to drop them in Discord. I'll make sure we get them triaged over to Tobias. All right, folks. It's been wonderful. Thank you so much. Have a good one.
Thank you so much. Bye.